Greetings and good evening, everyone. Warm welcome to all of you to a very special event arranged by Kuwait Mars rover Team Durbar Road to the Red Planet. Hope you are all well and safe in this corona pandemic situation and staying at home. NASA, National Aeronautics and Space Administration. I think there is hardly anyone who don't know about the name of NASA and dreamed about it. And today it's 18 February. Within a very short time, after a long journey from July 30, 2020, the Mars rover Perseverance is going to land on Mars within next 5 hours.
In this special day, we are here with you all to talk about Road to the Red Planet with two amazing speakers. But who we are? We are Team Durbar, a Mars rover team, together working to create a remarkable position in various rover challenges. We have secured 10th position in IRDC 2020 internationally and first among Bangladeshi teams and looking forward to more such competitions. এবং টিম দুর্বারের পক্ষ থেকে আমি আতি আছি আপনাদের সাথে।
এবং আমি আছি বিক্রয়। তো আমাদের ইভেন্ট থেকে শুরু করে পেজের প্রমোশনের মাধ্যমে আপনারা অলরেডি জেনে গিয়েছেন যে আমরা কতটা লাকি এবং প্রাউড। আমরা কতটা গর্বিত এবং সৌভাগ্যবান সেটা অলরেডি আপনারা জেনে গিয়েছেন। কারণ শত ব্যস্ততার মাঝে অনেক কাজ থাকা সত্ত্বেও মার্স রোভার পার্সিভারেন্স ল্যান্ডিং এর ঠিক কিছু আগ মুহূর্তেও আমাদের মাঝে সময় দিয়েছেন ডক্টর গৌতম চট্টোপাধ্যায় স্যার। স্যারের সম্পর্কে আমরা সবাই জানি এবং স্যারের ব্যাপারে যদি আমি একবার বলা শুরু করি তাহলে হয়তো স্যারের ওয়ার্কস এক্সপেরিয়েন্স, প্রোফাইল, অ্যাওয়ার্ডস প্লাস প্রাইজ এইগুলো নিয়ে আমি বলতে থাকলে হয়তো এরকম অনেকগুলো ইভেন্ট আমাদের লেগে যাবে। স্যারের ব্যাপারে আমরা যতটাই বলি না কেন সেটা কম বলা হয়ে যায়। তো আমরা আর বেশি কথা না বেরিয়ে চলে যাচ্ছি স্যারের কাছে। স্যারকে অনেক ওয়েলকাম। স্যার সম্পর্কে যেটা না বললেই নয়, স্যার বর্তমানে কর্মরত রয়েছেন নাসাতে অ্যাজ এ সিনিয়র রিসার্চ সায়েন্টিস্ট ইন জেট প্রপালশন ল্যাব। তো স্যারকে আমরা অসংখ্য ধন্যবাদ এবং ওয়েলকাম করছি আমাদের সেমিনারের মধ্যে এবং ইন দিস ভেরি প্রিসিয়াস মোমেন্ট অ্যান্ড লাইফ টাইম মেমোরেবল ইভেন্ট আই এম গোয়িং টু ইনভাইট ডক্টর গৌতম চট্টোপাধ্যায় স্যার অ্যান্ড হামলি ওয়েলকামিং স্যার।
Thank you all. A very good morning from here in Pasadena, California, where I'm sitting not too far from my home, our lab, Jet Propulsion Laboratory, where Mars rover Perseverance was actually conceptualized, designed, and built. So it's about 10 kilometers from where I'm sitting. So it is a very exciting time for all of us. But at the same time, we are anxious because it is never easy to land on Mars. So many things can go wrong, and everything has to work correctly. So it is always challenging, and I want to thank you all for joining in today, for listening in to this session. It is always exciting to talk to people, talk to young people, who are you guys are really amazing. You are so exciting, and you care about science, you care about technology, and that's why you are organizing this kind of event. So that gives me a lot of hope, and I'm really happy and proud of you all. Thank you very much for inviting me to this event.
ধন্যবাদ স্যার, আপনাকে অসংখ্য ধন্যবাদ আমাদেরকে এত ব্যস্ততার মাঝেও টাইম দেওয়ার জন্য। তো এবার আমি চলে যাচ্ছি আমাদের অ্যাডভাইজার স্যার হিলাল আর নাহিয়ান স্যারের কাছে। স্যারের সম্পর্কে যে কথা না বলতে নয়, আমাদের মার্স রোভার টিম দুর্বারের শুরু থেকেই তার একক প্রচেষ্টা ছাড়া আমরা কখনো এত দূর আসতে পারতাম না। তো আমরা স্যারকে ওয়েলকাম জানাচ্ছি। স্যার কর্মরত রয়েছেন বর্তমানে ডিপার্টমেন্ট অফ মেকানিক্যাল ইঞ্জিনিয়ারিং এ অ্যাজ এন অ্যাসোসিয়েট প্রফেসর। স্যার।
Hello, can you hear me?
জি স্যার, আমরা শুনতে পাচ্ছি।
Oh, thank you very much for giving me the floor. Thank you, Professor Gautam Chattopadhyay sir, for joining with us in this very moment. Actually, we are very proud of you to get you here, actually. And this is a proud moment for I think for the globe, actually, that the Perseverance is going to land on the Mars. And I strongly believe that this is just the starting step, and there's a lot more work to do, actually. And I think as a scientist, as an engineer, we have a lot more to do as well. And our students with us, we are still trying to make something to add some values in this work. So I hope your talk today will enlighten us and give us some guideline that we can also work in this arena, and our students also can join with you in the future as well. Thank you, sir. Thank you very much.
অনেক
Thank you.
ধন্যবাদ নাহিয়ান স্যারকে। এখন আমরা আমাদের স্পেশাল গেস্টকে পরিচয় করিয়ে দিচ্ছি। তিনি আইওটি মার্স রোভার টিমের ফর্মার মেকানিক্যাল অ্যান্ড সিস্টেম ইঞ্জিনিয়ারিং টিম লিড, আইওটি স্টুডেন্ট চ্যাপ্টারের ফর্মার প্রেসিডেন্ট। দেশে বিদেশে অনেক প্রতিযোগিতায় তিনি ও তার টিম বাংলাদেশকে রিপ্রেজেন্ট করেছেন এবং খুব ভালো অবস্থান রেখেছেন। তার রিসার্চ পেপার স্পেস এক্স হাইপারলুপের মতো টেক জায়ান্টও একসেপ্টেড হয়েছে। তিনি বর্তমানে আইওটি এর লেকচার হিসেবে আছেন। প্লিজ ওয়েলকাম তাসিম সেজাদ সানিয়াত স্যার।
Thank you very much for giving me the opportunity to be here today alongside Dr. Gautam Chattopadhyay sir and Dr. Nahian sir. It's truly an honor being given the opportunity to share my experience with the upcoming generation. I truly believe that people need to know, people need to love science. Like you guys are the future, and it's an honor being given the opportunity to inspire you guys. So thank you very much.
থ্যাংক ইউ ভেরি মাচ স্যার।
ধন্যবাদ স্যার। স্যার, তো প্রথমেই আমরা এই ইভেন্ট নিয়ে একটু কিছু কথা বলে নিই। আমরা যখন স্যার এই ইভেন্টটি প্রথমে লঞ্চ করলাম, তো সেই সময় আমরা সকল এনথুসিয়াস্টদের কাছ থেকে যাতে কোশ্চেন গুলো পেতে পারি, আপনাদের কাছে যেন জিজ্ঞেস করতে পারে, সেজন্য আমরা একটি ফর্ম ক্রিয়েট করি। এবং সেই ক্ষেত্রে যে জিনিসটা দেখা গেছে যে অনলি বাংলাদেশের ভার্সিটি স্টুডেন্টরাই না, স্কুল কলেজ থেকে 9, 10, 11 এর যে ছোট ছোট শিক্ষার্থীরা আছে তারাও এখানে আমাদেরকে কোশ্চেন পাঠিয়েছে। তো স্যার, আমরা কোশ্চেনের মাধ্যমে আমাদের ইভেন্টটি আজকে শুরু করতে যাচ্ছি। ধন্যবাদ স্যার আমাদেরকে চিফ গেস্ট হিসেবে আমাদের সাথে থাকার জন্য।
অনেক ধন্যবাদ। থ্যাংক ইউ ভেরি মাচ।
স্যার, প্রথমেই যে কোশ্চেনটি ঘুরে ফিরে সবার মধ্যে আসছে, সেই জিনিসটা হচ্ছে যে আমাদের আর্থের সাথে মার্সের অনেকটা তুলনা। এরকম আমরা দেখতে পাই যে আমাদের পৃথিবীর ক্ষেত্রে গ্র্যাভিটেশনাল ফোর্সের ভ্যালু হচ্ছে 9.8, কিন্তু আমরা মার্সের ক্ষেত্রে সেটা দেখা যায় 3.77, প্রায় 3/1 ভাগেরও কাছাকাছি। আবারও আমরা যদি এমনি অন্য এনভায়রনমেন্টের দিকে খেয়াল করি, দেখা যায় আমাদের আর্থের তুলনায় মার্সের সাইজটাও অনেকটা অর্ধেক, প্লাস ওখানে যে ইলেকট্রোম্যাগনেটিক যে ফিল্ড গুলো আমাদের পৃথিবীতে আছে সেটাও অনেক ক্ষেত্রে মার্সে কাজ করে না। তো স্যার, এই কোশ্চেনটা সেখান থেকেই অ্যারাইজ হয়েছে যে কেন আমরা মার্সের দিকে এখন ধাবিত হচ্ছে। আমরা কি সেই টাইমটাকে আর্থের এনভায়রনমেন্টকে আরো উন্নত করার জন্য কি ব্যয় করতে পারতাম না?
This is a very good question, and it actually comes very often, because whenever you spend money on science, people will ask why you are spending money on science, why not something else, why not water, why not sanitation. But we do not question when the government spend huge amount of money on defense, right? So we'll have to have a balance, because when we work on science, there is a fundamental science aspect to it that we are trying to understand, because everyone's mind, one of the biggest question is, are we alone in this universe? Where have we come from? How did all these things came about? And these are very fundamental basic questions. But on top of that, when we try to answer this kind of questions, we develop technologies, we develop understanding of science that has application in so many different areas. Just take the example of NASA. At NASA, we have people from all across, all the spectrum, in terms of, we have electrical engineers, electronic engineers, mechanical, thermal, biologists, physicists, chemists. So you think of any stream of education, you will find people working in this. As a result, when we actually, come up with something, you will find that a lot of advances in medicine, because we actually go through a lot of the radiation environment. So we'll have to learn what kind of effect radiation has on human being or other cells. But that is also very important for our medicinal research. If you think about it, right, cancer treatment is done through radiation therapy. So our understanding grows, and it always comes back to help us. New technologies that we are connected now through all this internet, right? So it is happening because we could, there is a video streaming going on. I can hear you, what you say. You are sitting in Bangladesh. I'm sitting here near Los Angeles, California. So it is unthinkable that it was possible some time back. Even, just a phone call was something, out of this world at some point. But now this is happening. This is happening because the technology has grown, and a lot of this thing actually came about because what we do in science and the arena of science and technology. So, and then why going back to Mars, this question? Because in early history of Mars was very much similar to our own planet. Like there is a lot of flowing water on Mars, and of course it is slightly further away from our sun. As a result, it is the temperature swing on Mars is like much more compared to what we see. However, there was flowing liquid, so and there was some river beds, there was some that lakes. And question is, was there any life at any point of time on Mars? So this is the major question we are trying to answer, and Mars is our nearest neighbor, where the possibility of life, we can learn so much that how things evolve, because it will give us a sense that in this solar system, in our solar system, how life actually came about on planet Earth. Are we really that unique that we think we are? So these are these fundamental science questions we want to answer, and that's why it is important to go to our nearest planet and learn as much as we can, because we are finding more planets far, far away, and we cannot go there, right? Because we don't have the technology, but we have the technology to go to Mars, and that's why Mars is so exciting, and we plan all these missions to go there and send all these instruments to do science experiments to learn as much as we can. And that is the main driver that actually drives us to go to Mars. So it is not a waste of money. It is not a waste of energy. And actually it advances our knowledge. It advances our technology that helps all of us. So I think it will be a myopic view to think that, amount of money that we spend, NASA's budget is only about 2 billion, $20 billion a year, and United States has GDP is about some $20 trillion. So it is a very small amount of money that we spend on NASA's budget, but the return on that is huge.
আশা করছি যাদের মনে এই প্রশ্নটা ছিল তাদের মন থেকে এই প্রশ্নটা দূর হয়েছে এবং তারা নিজেরাও সায়েন্স অ্যান্ড টেকনোলজিতে অবদান রাখতে আগ্রহী হবে। এবং এখন আমি সানিয়া স্যারকে প্রশ্ন করব যে স্যার আপনি কেন মার্স রোভার নিয়ে কাজ করা শুরু করলেন? এটার পেছনে রিজন এন্ড মোটিভেশন কি ছিল?
So I'm talking in English. I can talk, of course, talk in Bengali, but I know there are people, last time I had an event in Bangladesh, I talked the entire event in Bengali, and then I was told later on that a lot of people joined in from all across the globe. And of course, they could not understand. So please pardon me. It's not that আমি বাংলায় কথা বলতে পারি. It's not that I cannot, but I'm just talking in English just for that reason. So of course, I had a dream, like many of you and many people around the globe, to work at NASA, right? Because when you look up in the sky in a dark night, when you look at those stars and all those galaxies, it is intriguing. It actually asks you, that what are those? Where did they come from? So, and of course, the NASA is such an organization, has this name all across the globe that you feel, this is where the best people work. And when I came here, I found out that is so true. So I had this dream, and I actually came when I did my PhD from California Institute of Technology. I actually was asked, got a call to go and interview here at Jet Propulsion Laboratory at NASA, and I have been really lucky that I got that offer to work here, and I have been enjoying every moment of it, because here, as I said, the brightest people, the best and the brightest people, they're working. So I always tell people that if you want to be successful in your career, then surround yourself with people who are smarter than you. And that's what I have been lucky. All the people they work with me, I work with them, they are much smarter than I am. So that way I actually learn every single day. And then of course what we do is we do space technology. I got involved in a lot of different development, different technologies, so that we can have this kind of missions where my focus is on the instrument side, not on the landing part. Whenever there's a mission like this, what is happening today, that Perseverance is going to land, there are many layers of this. That one thing is that, okay, the rocket technology, because that's what is going to take you there. And then there is this navigation and guidance people who will actually navigate and guide it to. Going to Mars is not easy at all, and you'll have to have so much of calculations. So that why people ask why we send to Mars is can have only once in 2 years. That every 2 years only we can do that, because the reason is that when we are sending something, when our spacecraft arrives there, Mars has to be there, right? Because otherwise we'll arrive at a point and we see Mars has gone. So we'll have to time everything very well. We have only about 6 days of time in this time of the year where it is feasible. That both UAE and China also has sent two spacecraft to Mars, and all of them are arriving at the same time. The reason is because of this timing, that when we arrive there, Mars actually, when Perseverance is going to arrive, Mars is actually going to come back from there, because at the speed of Mars will be much higher compared to the speed of Perseverance spacecraft, because we will be at the top of that elliptical orbit that Perseverance rover has. As a result, we'll be at the peak of that, so our speed will be slightly slower. As a result, we'll arrive a little bit earlier, and Mars will come and catch up, and then we'll enter there. So I have been really lucky to get this opportunity to work at NASA and all these exciting different projects.
থ্যাংক ইউ ভেরি মাচ স্যার। এই এক্সপেরিয়েন্স সম্পর্কে শুনে আমাদের অনেক ভালো লাগতেছে। তো পার্সিভারেন্স সম্পর্কে পার্সিভারেন্স কেন হচ্ছে কি ডিফারেন্ট বাকিগুলো থেকে, বাকি মার্স রোভার থেকে?
Oh, because, okay, that's a very good question. Why we are sending Perseverance? One of the main idea of this mission is to find, is there life on Mars? Is there any sign of life on their Mars today? Or was there Mars ever habitable, in the sense that was there life on Mars at any point of time? And so over the years, we have sent quite a few rovers. Actually, we have been really lucky in that way that, for the human being, when we are trying to land on Mars, only 50% of the missions have been successful. And of that, but recent years, so past 20 years, the success rate has gone up because we have learned more and more. It has gone up to about 70% currently. So, but last 5 missions that NASA has sent for landing on Mars has been successful. So, but that puts a lot of pressure on us as well, so that we, we are successful this time as well. And, the mission, as I was talking about, that, that main mission is that to find if Mars was ever habitable. So we have chosen very carefully all those instruments that they are going to do a lot of experiments trying to find out. And also one of the key thing for this Perseverance rover compared to Curiosity is this will be the first step for Mars sample return. Mars rocks, they have layers, and in geological sense, we have layers of information. So what we are going to do is that if you can drill a hole through some rocks, and because where we are, you all know that we are actually landing at Zerozo crater, where there was a lake once. That's what we believe. And then if there is any life form that actually got either preserved or some signs that there was life, it is the best place to do those research. So if you take a stone or a rock from there, if you drill a hole, and what Perseverance is going to do is actually drill holes and take materials like a piece of chalk, that kind of, so we'll have collect 40 of those, chalk samples, kind of these rock samples, and but we cannot bring it back in this mission because we are not coming back. So what it will do, actually, to put in some metal cylinders and keep on Mars surface. So we are planning another mission, maybe 2026 time frame, that will go there, and it will have a lander as well as a rocket. So what that will do, the lander will collect all this stuff that we kept now, and then it will put it in a rocket, and the rocket will kind of a basketball size. All these samples will be there, and it will launch in space. And then again another mission in 2030 time frame, it will go and collect those and bring it back home. The reason is we cannot to do a proper experiment, proper study. The instrument that we need to send is much huge, a lot more power is needed. We do not have that capability to send it there. But on Earth, we have those capabilities. So that's why we'll bring it back, or that's our plan, to about 2031 time frame. And then we'll do those experiments to find out, is there any sign that there was life? And we'll know so much more. So that's why Perseverance is a very different mission compared to Curiosity that we had last time.
ধন্যবাদ স্যার, দ্যাট ওয়াজ অ্যান অ্যামেজিং পার্ট অফ দ্য মার্স রোভার অফ পারসিভারেন্স। তো স্যার এখন আমরা একটু সানিয়াত স্যারের কাছে চলে যাচ্ছি। যে সানিয়াত স্যার, আপনি তো আমাদের বাংলাদেশে যখন ইউআরসি বা ইআরসি মার্স রোভার সিস্টেমটা নিয়ে যখন কাজ করা শুরু করেন, তখন সেই টাইমে বাংলাদেশ থেকে খুব কম কম্পিটিশনেই টিমগুলো পার্টিসিপেট করতো। তো আপনার স্যার এইগুলো শুরু করার পিছনে মোটিভেশন কি ছিল, এবং তার মাধ্যমে কি কি এরর ডিফিকাল্টিস গুলো আপনি টের পেয়েছেন, এবং এগুলো কিভাবে আমরা ওভারকাম করতে পারবো নেক্সট জেনারেশনের মার্স রোভার গুলো দিয়ে?
আচ্ছা, সো আমার মোটিভেশন প্রাইমারিলি যেটা পাইছিলাম সেটা হচ্ছে ব্যাক when I was in school. So if I recall, it was when I was in 7th or 8th grade. তখন পেপারে একটা আর্টিকেল করছিল যে চুয়েটের একটা টিম নাসা লুনাবটিক্সে পার্টিসিপেট করছিল। So when I read that, I was really inspired, and I felt that I needed to be part of something like this. So তখনই আমি kind of mindset create করছিলাম যে when I go to the university, I will try my best to do something similar. So ওই মোটিভেশনটা আমার I believe স্কুল থেকেই ছিল। And then when I got into university during the first year, আমাদের কয়েকজন সিনিয়র, Sunny Bhai and Nishad Bhai, so they were planning to participate in this competition called URC, যেটা হচ্ছে University Rover Challenge, and এই কম্পিটিশনটা প্রাইমারিলি হয় হচ্ছে ইউএসএ তে। সো ওরা যে রোভারটা ক্রিয়েট করছিল, দে ওয়ার শোকেসিং ইট টু আওয়ার ফ্যাকাল্টি মেম্বার্স। সো আমি তখন ফার্স্ট ইয়ারে ছিলাম। সো দ্যাট ওয়াজ দ্য টাইম যখন আমি হচ্ছে অ্যাকচুয়ালি রোভারটা দেখছিলাম। সো ওয়েন আই স ইট, মাই motivation and inspiration that I had back when I was in school got rekindled, and so I was really motivated আর কি। So তখন থেকে আমি ডিসাইড করছিলাম যে I needed to work to become a part of this team that was working on rovers like this আর কি। সো আমি যেটা করছিলাম, আমি তো ফার্স্ট ইয়ারে ছিলাম, সো আই ডিড আ বিট অফ সেলফ স্টাডি। আমি ইন্টারনেট ঘেটে যে কয়টা রিসার্চ পেপার পাইছি, আই ওয়েন্ট থ্রু দেম, অ্যান্ড আমি একটা নিজের থেকে একটা ডিজাইন ক্রিয়েট করছিলাম, অ্যান্ড আই অ্যাপ্রোচড মাই সিনিয়র্স যে ওকে, I see what you guys are doing, and I'm really inspired and motivated to be part of this. So I did a bit of self-study, and this is what I came up with. So I presented them with the design that I, being a first year student, made. So they were really moved by the fact that I was so inspired and motivated. So they decided to take me under their wings আর কি। So তখন আমি অত বেশি জানতাম না, to be honest, but they prepared me and they mentored me in a way that I learned all the things. So that was my first introduction to the team আর কি। So slowly we started participating in the competitions. প্রথমবার obviously we did not make it to the main competition আর কি। So the competition has several stages. একটা হচ্ছে ফার্স্টে আমাদের একটা প্রিলিমিনারি ডিজাইন রিপোর্ট জমা দিতে হয়। Based on that they decide which teams go through and which teams don't. Then they invite the teams to present a video review detailing everything আর কি। So based on that they select a few teams to participate in the main event. They invite the teams to go over to the main competition ground. Competitionটা হচ্ছে Mars Desert Research Station, MDRS, Mars Desert Research Station. So Uh, the first time we participated, it was back in 2016. We did not make it, but in the subsequent years, we kept trying, and ultimately we did make it to the final events. আমরা দুইবার পার্টিসিপেট করছি। একবার হচ্ছে 2017-এ we participated in the ERC, যেটা হচ্ছে European Rover Challenge, and then in the following year we participated in URC and ERC as well. So
Thank you,
that's how
sir.
we basically got into the competition.
Yes, I hope our students and audience will be inspired hearing you. And now coming to Gautam sir, we are talking about perseverance, and perseverance have a unique feature like called Mugzi. So it's gonna produce oxygen in Mars. So we want to know how it will create Mars for us to habituate. Like কিভাবে এটা আমাদের বসবাসের যোগ্য করে তুলবে? Sir, you're muted.
Sorry about that. So I don't know whether it will become make all of us leave planet Earth and settle on Mars. But what the idea behind this, that of course in future we are planning to have astronauts reach there on Mars to do experiments. So one of the thing is, of course, oxygen that we need, and Mars environment is very, very different compared to our own environment here on Earth. So we'll have to create, we'll have to make oxygen there. So MOXIE is a very unique instrument. For the first time, it's a small instrument. It will go there and it will collect carbon dioxide from Mars atmosphere, and then through a chemical process, it will electrochemical process, it will split it up and create oxygen out of that. And we want to see that how much oxygen we can create. And then, because this is a very small experiment, so if it works well, then in future we can actually have a larger mission where we can create more oxygen, store them for future Mars astronauts. And at the same time, oxygen is very important in terms of fuel, rocket fuel. You can actually create rocket fuel out of oxygen and hydrogen. And then also our idea is that you can collect hydrogen as well from other sources, and then create water on Mars and for future astronauts. So that is the idea behind it. But it does not necessarily mean that pretty soon all of us will actually go there and settle on Mars, because it is amount of oxygen that we are going to create will initially don't be huge as well.
ধন্যবাদ স্যার। স্যার, যেহেতু ওয়াটারের কোশ্চেনটা অ্যারাইজ হলোই, ওয়াটার নিয়ে স্যার আপনি গত সেশনে একটা কথা বলেছিলেন যে আমরা জানি ওয়াটারের বিভিন্ন আইসোটোপ আছে, বিশেষ করে অক্সিজেনের 16, 17, 18, এবং সেক্ষেত্রে আমরা যেটা খাই, আমরা যেটা ড্রিঙ্ক করি, সেটা হচ্ছে 16 আইসোটোপের অক্সিজেন। তো আমরা অন্যান্য গ্রহে কি করে পানির উৎসটা ক্রিয়েট হলো, এক্ষেত্রে আমরা ধারণা করতে পারি যে স্যার হয়তো কোনো কমেট থেকে অন্য আইসোটোপের অক্সিজেন নিয়ে সেই জিনিসটা হচ্ছে অ্যাড হয়ে গেল। তো স্যার, এইটা নিয়ে আপনি বলছিলেন যে একটি কাজের ব্যাপারে আপনার, তো স্যার সেইটার অগ্রগতি সম্পর্কে একটু জানতে চাই।
It's very, very interesting and exciting, because when our planet Earth was created, there was no water on Earth, and scientists believe that the comets, the Dhumketu, they brought water to Earth. And when someone says this kind of thing, then question arises that how do you prove such a hypothesis that comets brought water to Earth? So then we'll have to actually look scientifically, right? You'll have to have a proof. And then we actually started looking at it, and it turns out, as Dipto was saying, that we figured out that, of course, there are different kinds of water on planet Earth, because oxygen has different isotopes. So the most prevalent kind of water that we drink every day is H216O, and of course there is H217O, H218O, as well as HDO. That one deuterium, one hydrogen, and oxygen also forms water. So if we actually take the ratio of all this abundance of these different kinds of water, as well as the D over H ratio, how much deuterium is there and how much hydrogen is there in this water, then that actually gives a very unique signature. And we are finding that one family of comets called Jupiter family comets, so they have very similar kind of abundance ratio that we find on planet Earth and what we are seeing on those comets. So if the abundance ratios are same, then very similar, then the source has to be the same. Or that's why we are trying to actually prove that, because we have already made only about 10 to 12 such measurements, not that many, not statistically very significant kind of measurement. So one of the things that I am doing currently is actually I am building an instrument. I call it WhatsApp. Of course, very acronym I came up with, a water hunting advanced terahertz spectrometer on an ultra small platform. So that is the idea. So it is about a very small satellite, shoebox-sized CubeSat, and there we are building very high resolution spectrometers to do exactly this, about this, measure these ratios and abundance ratios with very accurate measurement it can do. And advantage of this, since it is very small, we can make multiple of them, and we can go send it to numerous comets and measure that ratio on different comets, so that we have statistically significant amount of data, and raise this question. Then we also want to see from where water came on Mars. Of course, as one point of time we believe there was water, flowing water on Mars. So we also want to see, did also Mars got water in the same way, or maybe in a different way? So these are so many intriguing questions that we have to answer, and that's why we need all of you to actually come and join us and help us answering these questions. So we need young talents, we need young people, because you all are very smart, and you all are fearless. As we grow old, we become, our knowledge in a way and experience holds us back, because we know what is possible and what is not. That's what we think. But yeah, young people do not have that fear. They're bold and brave. That's why we need you all to come and help us answering all these intriguing questions.
ধন্যবাদ স্যার। স্যার, আমরা এবার একটু মার্স এবং মঙ্গল মহাকাশ থেকে একটু অন্যদিকে ব্যক্তিগত জীবনের দিকে আসতে যাচ্ছি, যেহেতু এই কোশ্চেনটাও আসছে অনেক দিক থেকেই। স্যার, কোশ্চেনটা হচ্ছে কি, আমাদের বাংলাদেশ সহ ইন্ডিয়া যেরকম বিভিন্ন কান্ট্রি যেখানে লোক সংখ্যা অনেক বেশি, সবাই ছোটবেলা থেকে এক ধরনের ড্রিম নিয়ে বড় হয়, কিন্তু বড় অবস্থায় দেখা যায় বিভিন্ন প্রতিকূলতার জন্য সেগুলো আর সাকসেস পায় না। অনেক ক্ষেত্রে দেখা যায় একজন মহাকাশ বিজ্ঞান অ্যাস্ট্রোনমি নিয়ে পড়তে চেয়েছিল, কিন্তু পরবর্তীতে সে সেই সাবজেক্টে পড়তে পারেনি। হয়তো ফ্যামিলি ব্যাকগ্রাউন্ডের জন্য কোনো সমস্যা, অথবা দেখা গেল সেই সাবজেক্টে সিট তত বেশি নেই। তো এক্ষেত্রে স্যার দেখা যায় যে অনেকেই পছন্দের জিনিসটা না পেয়ে আস্তে আস্তে হতাশ হয়ে পড়ে। স্যার, এই ক্ষেত্রে দেখা যায় যে তারা তাদের যে দিকে যাওয়ার কথা সেদিকে তো যেতে পারলোই না, এবং নেক্সটে যে দিকে আরো বেশি সাকসেস করতে পারতো, তাদের ওই পরিবেশ যে পর্যন্ত অপরচুনিটি আছে হাতের কাছে সেটা দিয়ে সেটাও তারা করতে পারে না। তো সেক্ষেত্রে স্যার অনেকেই আমি দেখছি যে ডিপ্রেসড হয়ে পড়ে। তো স্যার, এই জিনিসটাকে কি করে আমাদের ট্যাকেল করা উচিত?
I wish I had an answer for this, but I don't. But at least we can actually work together to find, what is very true, that of course opportunities are very limited, in particularly in countries like Bangladesh, India, and our subcontinent. But of course, things are improving. That is the great hope, and I hope that the government of Bangladesh and government of India, Pakistan, Sri Lanka, and Nepal, all these people, they will actually invest more, create more opportunities for, because so much of talent out there, as I have been saying, so much of, because smartness, no country has the hold on smartness. I have traveled to more than 35 countries around the globe, and I have seen that youth, the people are so smart, because everywhere you go you see that. Of course, the difference is about opportunities. So one of the things that I said, I also grew up in India, and of course opportunities were few. But one thing, that if you have to have a dream, of course, and then a drive and work hard, even if you'll find that maybe you don't get to where you want to go. Suppose you want to go to BUET or KUET, these kind of institutions in Bangladesh, maybe you didn't get admission because seats are very limited, and the selection process is also always based on one exam, perhaps. Maybe you were not well that day and you didn't do well. So one particular examination should not determine your future direction. So that's what I believe. So it's kind of sad, but that is reality. And then whatever you do, suppose you have to study something else, maybe in a local college you have to study physics and mathematics and chemistry. But if you study well, if you work hard, you will find that you will reach somewhere. Maybe not exactly what you have planned, but you can still fulfill a lot of your dreams in a different way. One of the things that you can do, suppose you actually do well in your BSc physics, and then do your MSc and go for PhD, and then from there you can actually still come to what exactly you wanted to do. So don't give up hope, because once we give up hope, we do not have something to look forward to, and that is one of the major problem. So that's what my advice, if I may, will be to actually do not give up hope. Keep trying, and whatever, if you work hard and whatever you're doing, if you are actually put your heart and soul to it, you can become a teacher and actually fulfill your dream through your students. Teach them well and show them the path, and then maybe they will be successful, because when you see your students are successful, that is much more satisfying than when you are yourself are successful.
Yes, sir. Thank you very much, sir. To sum up, sir, we have to say that don't be disheartened if you don't get the chance. Just dream and work hard. And if you can't succeed, just pass on the dream. And now I have a question for Saniyat, sir. That আপনি তো অনেকগুলো কম্পিটিশনে গিয়েছেন ইন্টারন্যাশনাল, তো সেখানে বাংলাদেশের অবস্থান আপনি কেমন দেখেছেন এবং কি করলে বাংলাদেশের অবস্থান আরো ভালো হবে?
So I'm really grateful that I had the opportunity to participate in several competitions, and I must say that Bangladesh still we are developing আর কি, like যদি আমি ইউরোপিয়ান রোভার চ্যালেঞ্জের কথাই বলি, I have seen that there are significant amount of participants from other countries, other developing countries, but বাংলাদেশ থেকে আমরা এখনো মানে ওই লেভেলে যেতে পারি নাই so that we can compete. But even if we are participating, দেখা যাচ্ছে we have significant resource constraints, and we do have budget constraints, যেটা kind of holds us back আর কি. But I truly believe that if you have passion for something, that is your biggest weapon to overcome these challenges আর কি. So I would say that the future generation of Bangladesh is very promising, and we are already seeing that through this seminar as well. So Team Durbar is doing a great job inspiring the future generations, and I do believe that through events like this, we will be able to inspire the next generation to take up the challenges that we currently believe are not possible from a country like Bangladesh. But I sincerely believe that it is very possible.
থ্যাংক ইউ ভেরি মাচ স্যার। অ্যান্ড নাও আমরা হচ্ছে আমাদের অ্যাডভাইজার নাহিয়ান স্যারকে ইনভাইট করব, আমাদের একটি অ্যানাউন্সমেন্ট আছে, তো সেটা বলার জন্য।
Thank you, Atia. Can you hear me?
Yes, sir. We can hear you.
Okay, thank you very much. Actually, there is an announcement for the young freshers, basically for the batch 2K19, because we are going to launch an internship program actually, and from this tasks you guys can learn about the journey of the Mars rover, and you can have the hands-on experience on the Mars rover. So and also we have several teams in our team Durbar, so the expert guys will give you some basic idea and also some hands-on experience, so how we can move on in the future. Actually, as maybe you know that we have just started our journey with the Team Durbar from our Kuwait campus, because this is the first team from Kuwait to start this kind of research, and I hope this legacy will be continued in the next days, next years. So we need to recruit the young freshers every year. So this is just the actually steps to recruit young students from the 2K19 batch. So that's why we are conducting this uh, seminar workshops. So I strongly believe, so our students will be interested, because we are hearing so a lot of informations from the Gautam sir and also Mr. Tasin. Thank you very much, you guys, for joining with us, and also thanks to the students for listening these valuable talks. And I hope you guys will enjoy the workshop later on. Thank you very much from my side.
ধন্যবাদ স্যার। আমরা আমাদের কুয়েটের সবচেয়ে জুনিয়র ব্যাচকে একটা ইন্টার্নশিপ প্রোগ্রামের আন্ডারে আমরা নিয়ে আমাদের মার্স রোভার গুলো কিভাবে কাজ করে এটার বেসিক থেকে শুরু করে অ্যাডভান্স লেভেল পর্যন্ত আমরা শেখানোর ট্রাই করব, এবং এর মাধ্যমে ওদের যে শুধু হ্যান্ডস অন এক্সপিরিয়েন্স এই অভিজ্ঞতাটাই বাড়বে না, সাথে করে তারা আমাদের সাথে পরবর্তীতে কাজও করতে পারবে এবং আশা করি পরবর্তীতে অনেক বড় পজিশনেও চলে আসবে। তো আমি আবারও চলে আসছি গৌতম স্যারের কাছে একটি কমেন্ট নিয়ে। স্যার, সুচিন্ত রায় ধ্রুব কোশ্চেন করেছে, স্যার, হোয়াট ইফ ইনজেনুইটি succeed to fly in the red planet, is there any chance that NASA will plan to send rover that can fly, or they will stick to the wheel driven rover?
So it's a very good question. That Ingenuity helicopter is a tech demo for us for the first time. We will be flying something on the red planet. But before I actually talk about Suchinto's question, it is I want to tell you that how difficult it is to actually design something like a helicopter for Mars, because atmosphere for Mars is almost 1% of our planet Earth. As a result, when you are building something to fly, you need that lift, right? For any helicopter or any flying object, you need that lift that has to come. And so when there is a helicopter on our planet Earth, the rotor blade that rotates is of RPM, that revolution per minute is about 450 to 600 RPM. That's what we need to have this proper lift because of the atmosphere that we have. And then, but on Mars, because of this very light atmosphere, the rotor blade has to rotate 2600 rpm, huge factor of 4 or factor of 5 more, and it is extremely challenging. But if we show that it actually works, then why we are doing this, though it is a tech demo, but in future it will really help us, because when the rover goes there, it has limited in terms of mobility, in the sense that it cannot really go everywhere that we want the rover to go. And I also saw there is some question that why can't we actually drive the rover sitting here. The reason is there is the time delay, huge amount of time delay. It at speed of light, signal takes more than 8 minutes to reach there. So you cannot really do kind of online driving when you have to take decisions on at a very fast pace. So that's why there is a limited mobility for the rovers where you want to go. However, suppose we actually have a lot of information from different Mars orbiters that is there already on Mars, like MRO, Mars Reconnaissance Orbiter, and then MAVEN. So they're already in Mars orbit. We got, however, when you go to the ground, you are always surprised. So what the helicopter kind of vehicle can do is that it will go around and it will have a lot of sensors. It will look around, it will actually detect things and find interesting places that we actually were not really aware of, and then you will tell the rover where to go. So yes, to your answer to your question is, in future, if we are successful with Ingenuity, we believe that we will of course think about this kind of helicopter or other kind of flying object that will be able to provide us additional information.
We are very hopeful. And now we have another question from Tibia Sanilor. That is, sir, the rover takes approximately 7 minutes to descend to Mars. The process has to be fully autonomous. Is the process smart and can take decision depending on the scenario, or is it a bunch of structured comment by doing trial and error method here on Earth?
It's a very good question, Tayeb, because there's one of the main difference between curiosity landing and perseverance landing is exactly this autonomous part. Because in previous time when we did not have this capability because we have all pre-planned everything was all pre-programmed and it used to land accordingly. But for perseverance, what we have is we actually took a lot of pictures on the location, the crater that where it is going to land, and also it is going to land within about maybe 10 kilometer, in kind of a diameter, area. So we have a lot of pictures. So those pictures are uploaded on Perseverance, and as the rover is going down, it takes picture, it has camera, it is taking pictures of that the area where it is supposed to looking down, and it compares, digitally compares with the database that it has and see if these matches the the terrain and all these features. If they match, then it knows that okay, we are in the right path. However, if it finds that it's not matching, then it has the autonomous capability to actually adjust so that it goes and lands, does not land on a big rock or on the mountain there, so that it crashes. So yes, so it has autonomous capabilities, and that's why we are very, very hopeful that it will be successful, because it will take some decisions on its own.
Thank you, sir. Sir, we know that working with NASA JPL is a great moment and achievement. And we also know that you have worked very hard through your childhood and got that success. So, sir, if I ask you one of the most memorable and emotional moment working with JPL or NASA.
So, I always tell that every single day is a memorable moment for me. I generally do not want to say, of course, because, there are a lot of such moments. It happened that when Curiosity landed, that itself was, huge, a memorable moment for many of us, because, it was such a challenging. We are sending something a huge rover for the first time. There are a lot of new technologies. That there's a sky crane technology that was being used, because when we enter on Mars, atmosphere, the spacecraft is traveling at a very, very high speed. And also we'll have to do everything very precisely. Many of you know that we use about 12 degree, 11 to 12 degree angle of insertion, so that as I was saying, that since Mars atmosphere is so light, thin compared to what we have on Earth, so there is not enough atmosphere to slow us down. So at the same time, if it is going about, let's say, when it actually we have a parachute on the rover, right? So when you deploy the parachute, the speed of the spacecraft is at that time about 1600 kilometer per hour. So we will never deploy a parachute on planet Earth if something is going at 1600 kilometers per hour, because it's too much of the speed. But still we'll have to do that. We don't have any other option, because we cannot slow down as much, because our atmosphere is not, Mars light atmosphere is not allowing us to slow down. So we'll have to deploy the parachute at that speed, and then of course it will slowly come down, and we'll have to fire some rockets and everything. So it is that landing of Curiosity was a huge, but every day is memorable for me, because I am so excited to go to work. Of course, now we are all working from home, but it is an exciting time for me, because so many challenges we are facing, and so many exciting novel and new things that we are working on. So that itself is a great excitement for me.
Yes, sir. Can see your excitement in your face, and we really hope that we can also get that excitement to work. And now I will love to ask Sania sir that আপনি যেহেতু আহ, মার্স রোভার নিয়ে কাজ করেছেন, তো কাজ করার আগে আপনার এক্সপেকটেশন কিরকম ছিল, আর কাজ করতে গিয়ে আপনি কিরকম দেখেছেন?
Well, to be honest, যখন আমি স্টার্ট অফ করতেছিলাম, I really had huge expectations, but when I started actually working on the thing, I realized how difficult it was. It's not as easy. So শুরুতে যখন স্টার্ট করছিলাম, I really had a lot of plans with the rover, but when we started working on it, we actually had to cut down and had to look at it from a much more realistic sense, যে what we can actually do আর কি. So I would say যে it was a very great learning experience though. I got to learn what that in board and paper things look great, but when you actually go and implement them, you come across these challenges that you never thought would come about আর কি. So I would say I had really great expectations, but when I actually started doing it, it turned out to be a lot more difficult than I thought it was going to be. So yeah, I'd say it was a great learning experience and an eye-opening experience as well.
ধন্যবাদ স্যার। স্যার এবার আমরা আবার গৌতম স্যারের কাছে ব্যাক করছি একটি কমেন্ট নিয়ে। স্যার তো রৌনক ইসলাম সে কোশ্চেন করেছে যে স্যার, as we know that the information is transferred through electromagnetic wave to Mars and vice versa, is there any way to reduce the latency?
Unfortunately, we are limited by physics here. So it takes time for light to travel at certain speed. And because given the distance that Mars and Earth is, we'll have that latency no matter what. Because that we cannot actually overcome physics here. So as a result, unfortunately, no. As long as we stick to electromagnetic, waves, we'll have this latency. Who knows? In future, maybe you will come up with an idea of communication through gravitational waves. Maybe that will help solving this problem.
Thank you, sir. I hope Ronak has got his answer. তো এখন আমি স্যারকে প্রশ্ন করব কমেন্ট থেকে একটা। আচ্ছা, আমরা এমনিতেই প্রশ্ন করি যে স্যার, জাহিদ হাসানের একটা প্রশ্ন যে স্যার, can you please share with what is NASA planning regarding the next mission on Mars?
Yeah, as I mentioned, there is of course a lot of things. When we are planning for next mission to Mars, it actually does not start now. The Perseverance rover thing, we have been thinking, our planning started in 2013. So it takes a long time for plan to materialize. As Tashin mentioned, that it is one thing is to think about on paper, and actually when you start what we call in this parlance about cutting metal, when you start cutting metal, it actually is very different story. As a result, we'll have to start thinking about all this much earlier. As I was mentioning, one of our next goal is to actually call the sample return. I mentioned that Perseverance will be collecting those samples, but we'll have to bring it back. So our next mission that we have been thinking about will be to actually have something to go there, to have a rover and a rocket that will land there, collect the samples, and also the rocket will launch it in Mars orbit, so that then we can capture that in another mission. We'll capture that and bring it back. So yes, that is one of them, because many other missions also on the anvil. We are thinking about all this stuff because the NASA has a very different way of thinking these things, because there is something called NRC, National Research Council here at United States. They have something called decadal plan, in the sense what is the big science questions that we want to answer in the next decade. And based on those recommendations, input from people, input from citizen scientists, everyone goes there, all these details go there, and then they come up with these ideas, and then NASA actually tends to follow those. And we build instrument, we build technology. So we are building something that will now that might be used on a NASA mission in 2030, in 2040. So because you'll have to build technologies, mature them, show that they're reliable, and only then you can fly them. So it is a very long process, but a lot of ideas on in the planning. But of course, at the end of the day, we are limited by resources as well, as I mentioned, how much money we'll have. And other than Mars, NASA also has a lot of other, exciting places to think about. So of course, how you allocate resources, those are also, comes into play.
থ্যাংক ইউ স্যার। আসলেই বোঝা যাচ্ছে যে জিনিসটা আসলেই কোনো কাজই সহজ না। এর মধ্যে অনেক কমপ্লেক্সিটি আছে এবং সেখানে আপনাদের মতো অসংখ্য সায়েন্টিস্ট ছাড়া মানে এই কাজগুলো আসলে সম্ভব হবে এটাও কল্পনা করা যায় না। তো স্যার আমরা যখন নাসার বিভিন্ন কোলাবোরেশন দিয়ে কোঅপারেশন করে যখন বিভিন্নভাবে কাজ করে, যেরকম আমরা দেখি যে ইউরোপিয়ান স্পেস এজেন্সি, কানাডিয়ান স্পেস এজেন্সি, তারপর জাক্সা, রসকসমস এদের সাথে কোলাবোরেশন করে নাসা বিভিন্নভাবে ডেটা কালেকশন করে কাজ করে। তো এই ক্ষেত্রে কি স্যার আমরা যদি কখনো ইএসএ অথবা জাক্সা এখানে কাজ করতে পারি বা এখানে যদি কোনোভাবে আমরা অপরচুনিটি ক্রিয়েট করতে পারি, তো স্যার সেক্ষেত্রে আমরা সেখান থেকে ডিরেক্ট নাসাতে যাওয়া বা ওখানে ইন্টার্নশিপ করার সুযোগটা কতটুকু পাবো বা এই ক্ষেত্রে আমাদের কতটা অগ্রগতি হতে পারে?
No, it's a very good question. Of course, NASA has its own internship program and it's open to everyone from around the globe. But of course, we have limited number of, because there are a lot of students and all the internships applicants from here itself, from within the United States. But still, it's open to people from outside. And it's not that if you are actually working in a European Space Agency project, only then you can apply to come to NASA. That is not true. You can actually apply from Bangladesh for those internship programs. But again, as I mentioned, it is very, very competitive and also limited number of seats, unfortunately. So if, as you mentioned, that we do have a lot of collaboration, because nowadays the challenges are so big and it costs so much money, it's very difficult to do a lot of things on your own. So, and as we work together, when we were kids, we actually had a short Bengali saying that doshe mili kori kaj hari jiti nahilaj. If all work together, and that's where success comes. As a result, you'll have to look at these as the global citizen, and then we'll have to all work together, and that actually helps us, and NASA believes in that as well. So that's why we actually collaborate with other agencies. So it is, so if you are interested, you should look into nasa.gov and see if there is an opportunities for you all to do internship and come here. And of course, if you can go to ESA, if you can go to JAXA, you can go to Canadian Space Agency, you can go to ISRO, Indian Space Research Organization, and many other places. And I hope that Bangladesh will have its own space agency if it is not there already. So then you can, all of you get opportunity to actually work there and also collaborate with NASA.
Thank you, sir. Get to know about a lot of opportunities. So now I will ask Saniat, sir, that what is the future of our country in this area, like rover challenges and other competitions? I want to know about it from you.
I would say the future is promising. এখন আস্তে আস্তে we are participating more and more in competitions like this, so that shows that 20 to 25 years down the line we'll possibly have a bright young workforces, or a bright young workforce that will be capable of achieving feats that we currently deem impossible. And also the government is taking certain initiatives regarding the aerospace sector. So I believe that incentives like this are going to help the upcoming generation to look into this sector more and more. I believe that for now, it's our responsibility to inspire the upcoming generation so that they are guided in the right path, and so that in the future we do have the prospects of being able to achieve feats that NASA is currently achieving.
ধন্যবাদ স্যার। এখন বাংলাদেশের ক্ষেত্রে মার্স রোভার চ্যালেঞ্জের ক্ষেত্রে যে মেইন অবস্ট্রাকল গুলো আসে বেশিরভাগই হচ্ছে ফান্ডিং রিলেটেড এবং আমাদের এক্সপিরিয়েন্সের অভাব রিলেটেড। তো এইগুলোকে আমরা যদি ওভারকাম করতে পারি, আশা করি যে আমরাও একসময় এরকম বড় বড় পজিশনে এই কাজগুলো আমরাও সহজে একসময় করতে পারবো। এখন
Yes,
শুরু, কিন্তু এটা শেষ না। তো
yes.
এখন আবার আমরা গৌতম স্যারের কাছে ব্যাক করছি। স্যার, স্যার আমার এখন যে কোশ্চেনটা অ্যারাইজ হয়েছে আমাদের বিভিন্ন এখান থেকে আমরা যে কোশ্চেন গুলো কালেক্ট করছি তার মধ্যে থেকে এই কোশ্চেন গুলো এসেছে। তো তার মধ্যে স্যার বেশিরভাগ কোশ্চেনই হচ্ছে মগজি রিলেটেড, মগজি নিয়ে মানে সবাই অনেক বেশি ইন্টারেস্টেড। এন্ড এইটা যে আদৌ হতে পারে সেটা নিয়ে অনেক ক্ষেত্রে আমাদের আগেও অনেক সময় ধারণা ছিল না। তো স্যার আমরা যখন বিভিন্ন এই যে এক একটা রোবট যখন লঞ্চ হচ্ছে, আগে কিউরিওসিটি, এখন পার্সিভারেন্স, নেক্সটে আরো কিছু যাবে। স্যার এই ক্ষেত্রে আমরা নেক্সট ফিউচারে যে রোভার গুলো ল্যান্ড করবে সেইগুলোর যে আমার ওয়ার্কিং ক্যাপাসিটি থাকবে সেইগুলোকে কেন স্যার আমরা ওই টাইপের জন্য ফেলে না রেখে এখনই আমরা এখানে কি ইউজ করতে পারতাম না?
আচ্ছা, good question. Amra, there is a limited amount of mass, that volume and mass that we can send, right? So we cannot send all the different kind of instrument that we think that will be useful on a single mission, because as you said, our capabilities are limited. What is the size that we can send, how much power is available, that is limited. So as a result, you will see our Perseverance rover has 7 different instruments. But again, all of these instruments draw about, let's say, 30 watt, 40 watts kind of power. And then if you add them up, it adds up. And on top of that, we have a helicopter as well that will also need power. So we cannot send everything at the same time, right? So as a result, we'll have to pick and choose. Of course, that is done through a very competitive process, and through that we have a science guidelines that, okay, we want to do this kind of science, this kind of experiments, submit your ideas of different instruments. And then from that competition, from this, very tough competition, people, they decide which instruments will fit in. Of course, it has to fit in on the rover. So there is a lot of different challenges. That's how we decide. That's why we cannot, even if you want, of course, ideally, we would like to have all the instruments flown to Mars at the same time, but we cannot do that. So that's why you have to pick and choose depending on what exactly we are planning to do, for what is the success criteria, what is the aim of this particular mission. So we'll have to split it up and do in steps.
থ্যাংক ইউ স্যার। তো আমাদের প্রশ্নগুলোর মধ্যে একটা প্রশ্ন অনেক বেশি ছিল যে স্পেস ট্রাভেল নিয়ে। তো আমাদের স্পেসএক্স, ব্লু অরিজিন, এটা তো হচ্ছে স্পেস ট্রাভেল ফোকাসড কাজ করছে। তো নাসার কি এটা নিয়ে কোনো আগ্রহ আছে এবং এটা নিয়ে কি কোনো কাজ করছে? আর আপনার কি মনে হয় যে স্পেস ট্রাভেল কখন সম্ভব হবে? আর এটা আমাদের জন্য কিরকম ইফেক্ট ফেলবে?
So space travel is very expensive. So also NASA's mandate is that we actually want to do science. So we develop technology, and we that there is a difference between NASA and some other space agencies, perhaps, because other space agencies sometimes maybe they aim science is there, but at the same time they also want to develop the capabilities for, let's say, communication, right? So for NASA it is about doing science. That's what we NASA has been formed to do. So it is not for space travel or space tourism for people. But of course, idea is that if we, as these different companies, they come and invest in space technologies, they can provide that space travel part. And I think it is going to, because if you see the progress that has happened for all these companies, SpaceX, Blue Origin, and many others, what they are doing. So it is, I'm very, very hopeful. And if you have money to spend, because it is still very, very expensive to actually get a ride. It will happen in future. Maybe it will, cost will reduce. So maybe hopefully everyone will be able to travel. At some point of time when I was growing up, air travel was almost unthinkable of. We used to all travel by train, but nowadays in India, everyone, because it has become much cheaper, it's a lot of opportunities, so people can travel by plane. Same way, maybe in some point of time, that you will take a vacation in space.
স্যার একসময় হয়তো দেখা যাবে আমরা যেরকম এখন বাংলাদেশ থেকে আমেরিকা ট্রাভেল করি বা অন্যান্য দেশে যাই, হয়তো তখন আমরা এক গ্রহ থেকে আরেক গ্রহতে যাব। হয়তো দেখা যেতে পারে আমরা হায়ার স্টাডিজের জন্য আমরা আর্থ থেকে চলে যাচ্ছি মঙ্গলে, মঙ্গলে যে ওখানে স্টাডি করে আবার আমরা ব্যাক করছি। অনেক কিছু পসিবল স্যার। স্যার তো স্যার আমাদের এক্ষেত্রে একটি কোশ্চেন আসছে, স্যার ডাস অ্যান আর্কিটেক্ট ওয়ার্ক উইথ নাসা? আই এম জাস্ট কিউরিয়াস টু নো। মেবি রীতি সরকার ইজ অ্যান আর্কিটেক্চার engineer, so maybe
Yeah,
that's the possibility.
why not? The question is why not? I'm sure that we also need buildings. We also need lab designing of the lab. So as you start thinking about it, you will realize that all these different aspects of all these different subjects are important because we have limited space, so we'll have to design our labs in a way so that it's very useful. It's actually connectivity, flow, and everything, and then an architect come and help us to doing that. Yes, we do. Of course, we have contracts, contractors, and all, but we have, as I said, A to Z, kind of subject matter experts everywhere.
Okay, sir. So we have another question that is, as far space missions, the more weight is, the more costly the mission becomes. So is there any project regarding soft robots to make the robots fit into small areas?
Yes, of course. That's what is actually happening all the time. Our aim, one of the things that we try to do is lower mass, lower power, lower volume, more compact. And, so that is the key to success, and specifically for going to planets, outer planets. Like, of course, Mars, it takes to go about 7 months, but if you want to go to Jupiter, it takes 7 years. So that is the key to how to make it more compact, how to make it lighter weight. So, research in material sciences, because that's where new materials will come, lighter, more, stronger materials. So all these stuffs is needed. And also you have to come up with architecture, not necessarily the architecture that the other question I was talking about, architecture of the instrument, that how do you stack things together so that it's more functional. If you look, all of you have smartphones, I'm sure. So you should have you opened your smartphone. That is a question I ask people. So if you have not, you should open your smartphone. Of course, it's not easy to open. You need some special tools. You can buy it on Amazon or online for about $10-15. So buy that and open your phone. I'm sure you are not going to break it. I opened my wife's phone. No, it was broke. It was water damage. That's why. So you'll see that what kind of architecture, what kind of packaging has gone into that. It's a kind of work of art, and that's we are doing, taking that kind of idea also, because it's not that everything is developed by NASA. So we actually look at what is going on around us, and if someone is doing something good, and we will, of course, we are open to actually using that kind of technologies. So packaging is a big thing for instrument building. As a result, it will be more compact, less mass, so that we can actually send one more instrument with the same mass profile. So those other things are very, very important.
স্যার দেখতে দেখতে আমরা প্রায় আমাদের আজকের এই ইন্টারেক্টিভ সেশনের একদম শেষ মুহূর্তে এসে চলে আসছি। এখন এত যে কোশ্চেন গুলো যদি করা একবার শুরু হয়, হয়তো আমাদের 1 মাসেও শেষ হবে না, যে পরিমাণ কোশ্চেন আজকে আমরা পেয়েছি। তো স্যার, আমরা অনেক 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 থ্যাঙ্কফুল যে আপনারা আমাদেরকে সময় দিয়েছেন, এবং শুধু যে আমাদেরকে মহাকাশ বিজ্ঞান, জ্যোতিষচর্চা এবং মার্স রোভার, মঙ্গল, বিভিন্ন গ্রহ উপগ্রহ সম্পর্কে আমরা যে জানতে পেরেছি তাই শুধু নয়, আমরা আমাদের জীবন, আমরা ক্যারিয়ার কিভাবে তৈরি করব, আমাদের লাইফ গুলোকে কিভাবে আমরা স্মুথলি আগাবো, এরকম প্রত্যেকটা ব্যাপারে আমরা ওভারঅল একটা ধারণা স্যার আপনার কাছ থেকে পেয়েছি। ডক্টর গৌতম চট্টোপাধ্যায় স্যার, আপনাকে অসংখ্য 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 ধন্যবাদ আমাদের মাঝখানে এত শত ব্যস্ততার মধ্যে আসার জন্য। এবং আমরা কুয়েট মার্স রোভার টিম দুর্বারের পক্ষ থেকে আমরা আসলেই সবাই অনেক অনার্ড যে আপনাকে আমরা হোস্ট হিসেবে, আমরা আপনাকে চিফ গেস্ট হিসেবে আমাদের মাঝে পেয়েছি। এবং শুধু কুয়েটের সকল স্টুডেন্ট না, সারা বাংলাদেশ এবং সমগ্র বাংলা ভাষাভাষী এবং ইন্টারন্যাশনাল সকল স্টুডেন্ট, সবার পক্ষ থেকে আপনাকে অসংখ্য অসংখ্য ধন্যবাদ। এবং সানিয়াত স্যারকেও অসংখ্য ধন্যবাদ আমাদেরকে মার্স রোভার নিয়ে আমাদেরকে একটি ওভারঅল ধারণা দেওয়ার জন্য। বাংলাদেশের প্রেক্ষাপটে কিভাবে এই জিনিসটা নিয়ে স্বল্প রিসোর্স নিয়ে আগানো যায় সেটা আপনাদের মাধ্যমে আমরা শিখতে পেরেছি। তো আমরা এই সমাপনী অবস্থায় প্রথমেই আমি সানিয়াত স্যারকে অনুরোধ করব কিছু বলার জন্য, এরপর আমরা চলে যাব স্যার গৌতম চট্টোপাধ্যায় স্যারের কাছে। সানিয়াত স্যার।
Thank you very much. First of all, I'd like to congratulate Team Durbar for organizing such an event. I believe that events like this are necessary to inspire the current generation as well as the future generation. And it was truly an honor being invited to the same event as Dr. Gautam Chattopadhyay sir. I'm truly honored, and thank you to you guys as well.
Sir, we are really very proud and it's a really honored, we are really honored for that যে স্যার আপনি আমাদেরকে সময় দিয়েছেন এবং আমাদের বাংলাদেশে আপনাকে স্যার অবশ্যই অবশ্যই আমন্ত্রণ থাকবে বাংলাদেশে এসে ঘুরে যাওয়ার জন্য এবং অবশ্যই স্যার আপনি আমাদের কুয়েটে আসবেন এবং আমরা সর্বোচ্চ চেষ্টা করবো আমাদের বেস্ট করার জন্য।
Nishchoy, I am looking forward to the day when I'll be able to go to Bangladesh. As I said, I actually have never traveled Bangladesh. I live, from the distance I was checking recently because I was calculating that, when the Mars rover currently is going at the speed of about 75,000 kilometers per hour. And so if we go to by that speed, the distance between Kolkata and Dhaka is about 350 kilometers by road. If by that speed it will take about 15 seconds, less time for Usain Bolt to cover 200 meters. So that is the time it will take for me to reach from Kolkata to Dhaka. But unfortunately, I have never been there. So there is a saying, Rabindranath Tagore had said that, দেখা হয় নাই চক্ষু মেলিয়া ঘরে তো শুধু দুই পা ফেলিয়া একটি ঘাসের শীষের উপর একটি শিশির বিন্দু. So my situation is similar, that I'm very, I'm so unfortunate that it has not happened yet. I hope it will happen in future. So I'll surely like to meet you all in person and talk to you. I'm looking forward to that day. And now I'm looking forward to, in a couple of hours time, that, hopefully everything will go well and Perseverance will land safely, because it is, how much ever time we have done it, it is not easy. It is not easy at all to land something on another planet. It is extremely challenging. So hope everything will go well and it will be successful. But there is a lot of challenges. So we should be mindful of that. There is there are risks are there. So hopefully there'll be good news. And again, all of you, it's already very late in the night in Bangladesh. So I
না স্যার,
want to tell you all good night. And I have my day ahead. তোমার হলো সারা, আমার হলো শুরু.
থ্যাংক ইউ ভেরি মাচ স্যার। আমরাও অনেক হোপফুল যে পার্সিভারেন্স ঠিক মতো ল্যান্ড করবে এবং এখানেই গৌতম স্যার এবং সানিয়াত স্যারকে অনেক অনেক ধন্যবাদ জানাচ্ছি। আর আমাদের প্রশ্নে এত চমৎকার উত্তরের জন্য আবারও ধন্যবাদ। আমরা তো অবশ্যই আশা করছি আমাদের অডিয়েন্সরাও অনেক ইন্সপায়ার্ড হয়েছেন আর তাদের অনেক প্রশ্নের উত্তর পেয়েছেন, অনেক কিছু জানতে পেরেছেন। সবাইকে ধন্যবাদ দিয়ে আমাদের ইভেন্টটি এখানেই শেষ করছি।
Thank you.
ধন্যবাদ।
Bye.
Bye.
গুড মর্নিং স্যার।